So sorry again, let's start Pragmatic design system. How to structure your design system when you don't have designers. Or in fact, when you have designers, but they are not like working in daily life on the design system, they are not part of the design system team, and things like that. So about me, Thibault. So I'm front-end developer for around a bit more than 12 years now, mostly React, what I like. I will strong focus on UX, agile, code craftsmanship. I really love to create a reusable product, a usable product, sorry. I really love to clean code, and I'm implementing design system for around 4 years now, and the maintainer of two tools. So like I said at the beginning, it's kind of the volume two of React pattern guidelines. And I'm gonna re-explain most of the main patterns that I consider useful. I did a few more, but I'm gonna kind of skip a significant part of the storytelling, why you need to make really clean component. We're gonna consider today that you need to make components that are reusable as much as possible, and not have, for example, in the middle of a design system component, if feature A, do that, else do that. Like this kind of thing we really don't like. If you are not, you don't trust me about that some bad pattern should be avoided, just check the first presentation. But we're gonna go for the patterns. So first of all, what is a design system? So I don't want to go too deep. It's a set of several things. It's a set of standards and guidelines. For example, which kind of platform you want to support or not support. For example, if you have a design system for an application on a car, maybe you don't care about the desktop and you say, okay, my system is that. I need to support only this kind of screens. So guidelines is also, for example, what is the principle behind the design system? For example, material UI of Google was putting everything based on paper, different layering, everything like that. So that it was part of the guideline and standard of MUI, material UI. There is a style guide. Style guide is everything about the color, the typography, the radius, the paddings, all these kind of spacings, all these kind of things. And there is always a third part that is the components. What are the components in your design system? So with this kind of, when you have a design system, you have the benefits. So first of all, you have a consistent user interface. So it means that if you create a component once and you reuse in several places, you are sure that's going to be the same one. You won't have like one day a button with a 10 pixel border radius and a second one with 20 pixel radius, 20 pixel border radius. And it accelerates also the development because, for example, especially when you have to deal with accessibility, I'm going to give an example. For example, we have a component that is a credit card input. So it means it's an input field where you can put your credit card. But if it's inside the design system and you can reuse it several times, you know automatically all the accessibility gonna come with that. Like all the issue with autofill and things like that, gonna automatically add it. While if you had to implement every time the same input, you will need to implement all the accessibility around, and you lose a lot of time. But a design system is two parts. There is a design part and a development part. So it means when you have a design system, you need to have like some people working on the design, spending hours on Figma, for example, to see how they're gonna design this component. And after, you need to have like the implementation. And both of them need to be synchronized. And they are both part of the design system, because if you have a design system only on Figma, thank you, but the developers, they're gonna every time re-implement the same component, even if it's in the Figma. And they won't reuse the accessibility. Every time they're gonna need to re-implement this accessibility, for example, for the credit card input. And at the opposite, if you have only the development, it's not easy at all either. So that's where we're gonna start. So in the ideal world, you have a strong design system team. So if you can take team in Desjardins, Canada Life, or any other big bank, and that are really careful about accessibility and design system, most of the time you should at least have designers, front-end developers, and accessibility experts at minimum. And so when you have this kind of vision, it's a bit easier to implement a component and to maintain this component because you know, based on the vision of the designer, you know how many variants you're gonna get. For example, if I give the example of a user card, the designer gonna say, yes, I know where this component is used, and I can tell you developer, front-end developer, that there will be 3 variants: this one, and this one. So you can just implement one React component and say, okay, there will be a variant A, B, C, and you can even make it a bit hard-coded if A do that, if B do that, if C do that. You know, it's maybe not the best, but it works. Like there is no problem with that. But for that, you need to have designer telling you, I'm sure there will be A, B, C. Maybe in the future there will be a version D, but they will tell you ahead of time and say, okay, next month we're gonna implement a version D. And it's you as a front-end developer part of this design system team that you're gonna be able to prepare the work so that after all the other team can use these components. In the real world, it's a bit different. Sometimes you don't have designers. Sometimes you have designers, but for example, they are more like feature designers. So they are more in charge of implementing the next feature that's going to be implemented in your product. They are not just in charge of the design system. Maybe they are not at all in charge of the design system. Maybe they don't have vision of what's going to be next month, what's going to be next year. And sometimes these designers, they really like you know, especially the UI UX designer, they're a bit artists. And sometimes they like to create a new component, look like a previous component, but not exactly the same. And it's not in the design system, or it was, the version A was in the design system, but not the second version. And they don't tell you until the last minute that it's in the mock-up that need to be implemented next week. So not so easy. So, however, when a company start to implement a design system, they still start to care a bit and at least putting some developer on it. Maybe not designer, but at least one developer. Or it's not his main task, but still he's the one reviewing the PR and things like that. So there is still someone, because anyway, at the end, if you don't have any developer, any designer in your design system team, good luck, you don't have design system. So imagine you are a front-end developer, you still have to maintain and create a design system, but you don't have so many designers, you don't have a product vision on this side, and what you're gonna need to do. So you need to do pragmatic. So first part, you skip the guideline. Like guideline will be something a bit dreamy, but you skip totally. You think, okay, I'm gonna need to deal just with daily life feature, and that's all. No big vision of what is inspiring my design system. Is it a paper style? Is it like more like a glass style, like the new Apple design system? You skip all this part. You try your best to extract the style guide from the feature mockups. So in the feature mockups, for example, if there is a makeup about a payment page, you see, oh, in my payment page there are all these colors. So I guess this color should be part of my design system. And step by step, you extract all the color, all the typography, all the padding, spacing, all these things from your feature mockup, and you start to put them in your design system until you think you have enough of them to freeze this color, freeze this typography, freeze this spacing, and say to the next one, no, sorry, it's not part of the design system, so you need to change your Figma. And that's really the part I really want to talk tonight. You have to be the one building the component library. There won't be a Figma version and a code version. There will be only a code version, but you need to find a way that they are flexible for unknown variants. So maybe tomorrow there will be another variant, and you still need to find a way to have your component generic enough and flexible enough to accept this new variant. But in the same time, you still need to find a way to enforce consistency, because you cannot just accept everything. Otherwise, if you have a component with something, a button with a 10 pixel radius, you shouldn't accept a button with 20 pixel radius, maybe. So For the step one for me is really easy. You just go with an existing library. Okay, like don't start from scratch. For me, the first to go are really MUI and ShadCN UI. This one is more like Tailwind based. This one is a bit more old school, heavy React component, but they are both doing the job great. And they really help you to structure specifically your theme. How you handle the colors, how you handle the typography. Both this one do that very well, so just go with these two. And after, if your company is really larger and you can invest more time, you can really check on design. It's really great too. It has less components than MUI. From my point of view, the ecosystem is smaller. It's a bit smaller than MUI, but I think the components are also lighter than MUI. MUI, that the one we are using in our company, is really heavy component. And maybe sometimes if you have really performances issues, don't go with MUI. Or you just go with a raw Tailwind and up to you to build the design system on the top of it. If you have a company that is not so small, it's like if you have at least 2-3 developers in your design system team, I think it's really possible, no problem.
Company, there's also a carbon design system.
Okay, I will check that. After, second step, something that you see very often, people tell you, go with atomic design. So that's the way to go for design systems. That's the best way to structure your component. You're gonna have atom, molecules, organism, template, pages, things like that. It's cool. It's very cool in theory. In practice, when you have a component, say, what should be? Should be atom, a molecule, an organism? What is it? And also for me, design system is not a one size fits all solution. And specifically, when, for example, imagine you are a bank. In your design system, at some point, you might still need like a payment form. And because you might need to reuse it in a lot of places. And so this payment form is maybe a bit like, still start to have some business logic inside. You might have like a user form when you need to input first name, last name, email, phone number. And this guy too might need to be in your design system. So when people show that, most of the time it looks like a component library, like you are redoing MUI. Yes, it's super easy to know what you should put in which part. But when you're actually doing your design system that is matching your business, you have the right to put components that are really strong business logic even inside the design system. So just the goal is to be sure that if they are reused at least in 2, 3, 4 places, they should be maybe in the design system. So my approach is a bit different. I'm still gonna keep atom, molecule, organism. And one thing I like to do is like atom, no domain specific. So it needs to be like something that could be in my company or another company. Most of them, they are a bit more customized depending on my style and my theme. So it can be, for example, I don't like the way the dialogue is implemented in MUI, so I'm gonna re-implement my own pop-up. Or maybe a pop-up on the top of the existing pop-up, but with extra feature. For example, the close button is a bit different. That's the atoms. The molecule, for example, could be for example, a card showing all the detail of your credit card. If it doesn't require extra logic or something like that, it can be there, like just showing credit card number, expiration date, and CVV. Boom, could be a molecule. Organism, the same. After, it's where you start to have business. For me, the difference between molecule and organism is more if you start to have extra business logic. If it's just a UI component that's just rendering, I like to keep them as atom or molecule. But organism for me is more like things that you really start to put logic inside. For example, some form validation, some error management, some yes, this kind of thing like a validation. For example, if you have just displaying a credit card, maybe it could be a molecule. It has some domain-specific feature, but no business logic, just rendering a component. But for example, if it's a user form that you need to check that the email looks like an email, that you need at least the first time and last time, otherwise you don't, the submit button is disabled. Maybe it could be some kind of organism. And after it might at the end automatically imply something. Is like, for me, atom and molecule, you need to find a way in the architecture that you can have infinite variant of these ones. For example, an input, if we take, for example, I recreate a text field, an input text for an atom. When I say infinite variant, is maybe one of them can have one specific icon at the beginning, but it can be another icon. For example, it can be an icon of email, an icon of a user, an icon of credit card icon, thing like that. So you can have a lot of them. Same thing for molecule. However, for organisms, the goal is like start to reduce a lot. For example, if you have a user form, you don't want to have 100 versions of your user form with sometimes there is a first name, last name, email, phone number. Sometimes the phone number is not there. Sometimes the email is not there. You want to make it more straightforward because you start to have like some business logic. So when you have business logic, it's not the time to start. If this field is there, do that. If this field is there, do that. You don't want that too much. But at the end, the important thing is still to try to find a way to categorize between atom, molecule, and organism so that you don't have a plain one folder with like 500 components directly inside. You start still to want a bit of structure. Step 3, that's the part important for tonight, and I hope you are all awake because it's gonna be a good gallery of patterns. So I'm gonna go through all these patterns, but since we are not a lot of people, feel free to stop me at some point if you really don't understand anything. The goal also, you're gonna see that a lot of patterns have really weird name, and sometimes the name can be like, you have the word like prop, slot, render that happens a lot in all these patterns. Don't care about the name, just try to understand what is the principle behind the pattern. So first one, we're gonna start very easy, composition pattern. I think this one, everybody used it in React. And the goal is like just like you have a property that you consider that is, for example, in a TypeScript React node, and you render it. And so that when you call your component, you can provide directly a React node as a property. It's an easy way to have a component that can have infinite number of variants. So it means that this field, you can have a clear button, you can have a check indicator to tell you that the data is valid. You could have like, instead of this one, an indicator of a credit card that to show that it was able to detect which kind of credit card it is. Is it MasterCard, Visa, thing like that. So, well, good example of what could be an atom. Second one, React slots pattern. So on purpose, I did a very weird example to show where we can go. I don't suggest to always go for input with this pattern, but that's the way to show. So the hard part is like children. I think everybody knows what is a children in React. Okay, the same is kind of basic composition pattern. But when you get the children, in fact, so you have this function to transform the children as an array. And you can go through these children. You can go through the children and check their type. So maybe this part gonna be more understanding. So when you have an input, you can use some component, and you're gonna say, okay, I want this one inside the start decorator and this one in the end decorator. So it's another way to do composition. You know, you could have easily create start decorator and end decorator as just two properties. But instead of creating them as two properties, I just put them all in children, and I find a way to filter through these things. So most of the time, you don't do that for input, okay? But it's more useful for models, cards, or things like that. But sometimes when you see for models and cards, people say, yes, it's obvious, it's just using the normal composition pattern. No, this one is a bit different. Because you don't render all the children as one. You see, like I never render all the children. I just split them. I'm able to detect, okay, in my children, there is this one that should be there, this one that should be there. So you can put something in the middle, for example. You can remove some of them if, for example, there is one you think it shouldn't be there, or things like that. So this one is really, really useful when, in fact, you don't know how many of them you're gonna have or things like that. I would say that explicitly. If you wanted to use a property, you have to define all the property at the beginning in the component, and it could be a bit painful, specifically if the property have a huge React node. Like while there, it's you just put one indentation. It's a bit easier to understand. Third pattern. Sometimes composition is not enough. You want to have like some kind of interactivity. And when you see this version, the input cannot interact with this one. Can just render it or not render it, but that's all. No interaction. So this one is easy too. You have one property, and in fact the property is not a React node, it's a React component. So when it's a React component, I can just call it like this. But the nice thing is like I can provide some properties. So the render prop has two variants. One of them is like you pass, for this one, you pass a function. The other one is you pass a component. The function one, I didn't show it there. It's inside the GitHub, but it's not there. The one with the function, the nice thing is like it's really easier to write. You can just inline a function there. The pro, or however, of using a component is that you have all the life cycle of a component. So you can have some use effect inside. You can use the context inside. You can start using having more things, while with a function you cannot. After you have the trick to consider a function as a component, but you need to be careful with React compiler of React 19. It doesn't work very well. So with the first three patterns I presented, we use all the same principle from the solid principles. It's an inversion of control. So it means that instead of rendering directly the logic inside this component, inside this input, I decided to say, okay, I don't know everything, so I'm gonna let my parent decide for me for some part. So for example, this guy, he doesn't know what's gonna be this one. He just say, okay, I don't want to care. My parent gonna decide what to render in this guy. So that's the same for composition. That's really like this. React slot is just a smarter version for composition, really like this, and render props the same. But when you start to extract some logic, some UI or some logic from the component and put it in the parent, you might have duplication coming. Because imagine, for example, if we go back to if you go back to this one, and you say, okay, the parent decided that I want to show that and that. Imagine now you want this component in three places. Three places in the UI, you want a component with an envelope at the beginning and a clear button at the end. You're gonna start to have duplication in all the pages that you want this logic of this one there and this one there. That's the problem with when you come with inversion of control, you're gonna have duplication. So there is a fourth pattern for that. So this pattern, the important is just to focus on the beginning, this part. You have your component, and you pass some props. You have the right to pass props to a component like this. This function just needs to return an object. And that's as easy as that. So for example, my function there, return a value, unchanged, undecorator. So most of the time, we like to use a function just so that if you need to, if this input is inside a loop, you can call it several multiple places, things like that. So most of the time, this pattern always comes with a function there. In theory, you could just return directly the properties as an object and use the object there, but that's not what we do most of the time. We prefer function in case of loops and things like that. So, are you able to understand this pattern? Is it complicated? Or so the nice thing is, like for example, let's say the logic of a credit card. that is reused in several places in the code. Then you just need every time to just call this one and that, and up. You know that you have automatically an input with a credit card logic. So I can try, but for example, 1, 2, 3, it works well. If I try to put a number, letters, it doesn't work. And if it's finished, put the check. So everything and all the logic is inside this hook, and there is not so much duplication anymore. You can just say, okay, this input, every time you want all the logic of a credit card, just do that. That's all. So right now, everything we did the atoms. Atoms and molecules, we found a lot of patterns to be able to have our atoms and molecule reusable using composition, slots, and propagator. Not propagator, function render. And propagator was able to, on the top of the molecule, this pattern is not to be used inside the molecule. There you call the molecule, and this one is more like directly on your page. But sometimes, if you start to have this kind of things a lot of time, you say, okay, like, what should I do? Like, if you start to have a lot of duplication of these things, maybe you should put all this logic inside an organism, because that's the goal of organism, to carry some internal logic. And so to avoid the duplication, but still maintain the consistency, we need to change a bit the paradigm inside the organism. The goal of the organism is like, this time, instead of accepting all the variants, I'm gonna say, okay, I can accept all the variants, but by default, I have one. We can override each small part, but by default, there is one. And this paradigm will gonna really help that by default, when the developer use your design system, if on purpose they don't change one behavior, they have something the same as the other people. And that's important, that by default, they have the same as the other one. It's not the case for the atom and molecule. The atom and molecule will come a bit like really open. They don't have some, thanks to inversion of control, they don't have the feature. For example, this input, if you don't say anything, it doesn't have anything. So it's a bit the opposite behavior, the opposite logic between atom and molecule on one side and organism on the other side. So for example, you say that by default, if you, for this calendar, if you don't customize anything, it looks like that. You say, well, there is everything. There is already some logic because you have all the dates. You have a picked day there. You have the clear button to unselect the date. Voilà, that's your default variant. And one first pattern to still help them to be customizable, but it's optional. And the first one is called custom slots. It's coming from MUIX. It's something, so MUIX is a sub-library of MUI, and they do this pattern a lot in this library. So inside your component, inside your calendar, you're gonna say that, for example, there is this component. This component is called the action bar. There, as a custom slot, you're gonna say, okay, for the action bar, I want to override one of these one property actions. So in fact, it's just each organism lets you override all these subcomponents, all of them, or at least you choose the one you want to be able to be overridden, and you just pass, okay, the action bar. By default, it had already a property action, I guess, that was called clear. But this time I'm gonna change and say, okay, I want two of them, today and clear. So this one at the opposite, all the logic is already inside the organism. And inside the organism, there is some places, if, else, But the goal is really to keep it inside so that there is less chance that some developer do extra things. Is it clear or not?
Can you change one of them, like change it today to something else?
I cannot do it live.
Oh, you can't do it live.
No, sorry, it's not a text editor.
I thought it was.
No, but yes, in the implementation it will work actually. So yes.
It was live on the right, so you know.
Yeah. The right is interactive, not the left. You're right. So one level above, harder, I mean, is instead of slot props and overriding the properties, you want to be able to override the components themselves. So it means that, for example, you're gonna say, okay, the action bar, it was a component. But this one, I say, okay, like, I don't want to override one property of the action bar component. I want to use my own component so that I can override whatever is inside. So that's the case. Well, in this specific case, I didn't do crazy thing. I just say, okay, I didn't like the way that the clear was rendered. I want an X across instead. And voila, it works. Voila. And so this one is again something similar. Like it's something optional. And it's to help you to, in really a specific case as a designer, like if we go back to the beginning, you don't have a product vision. And you have one day a designer say, for this calendar, I'm gonna put a cross. And you see the designer, like sometimes I try to challenge the designer and say, hey guy, like, please. But sometimes it still come like this. Now, in this specific situation, I would definitively challenge the designer, say, no, like, you stop that. But for example, he said, no, I don't want a cross. I want, for example, tomorrow. Well, maybe you can click and say, I want today or tomorrow. Bon, there you would have the option and to put, okay, instead of the clear action, I'm going to create a new action that is called tomorrow. Maybe I should have used this option for the demo. And so the goal of these two patterns is really to give you no limit. So whatever you want to customize in this component, you are able. But it's optional, and it's really like, it's a bit like you need to dig inside the component to understand what you can customize or not. We don't want to make it totally free access and almost like by mistake, they customize the component. No, it shouldn't be by mistake. It should be really on purpose. They really check, okay, on the designer gave me that with that it was different from the previous version of the calendar. So I absolutely need to override this component. That's a bit the paradigm with the organism. And after there is very similar one, okay? You just do all this override using context. Because sometimes an organism is inside an organism that is inside an organism, and you don't want to do props drilling hundreds of times. You just say, okay, like for the whole page, I'm gonna say that this action, or whole page or even whole product, because sometimes the design system is shared between different products. For example, it can be between a consumer version of the application and admin version of the application, things like that. So you say, okay, for all this page or all this product, I want that the action bar looks like that. So of course it can be with slots and slots props, the two last pattern I presented. And to be honest, us in our company, but we start to use that from time to time because we have to override for like components that are like a 10 level below one small component, and we use it. When you see that, you say, okay, like there I'm creating an object to pass to a props. Is it impacting the performances? Yes and no. No, because with React 19, there is some memorization automatically. So no for this part. But yes, on the part that everywhere in the code, I need to check if this props is provided, I need to do something. Otherwise, I need to provide the default component. So all this conditional rendering everywhere in the code or the way to override the property of putting every time add to this structure the previous property and add the default properties and things like that. This part definitively add extra logic, extra computation. So yes, but not as much for the providing an object in a property instead of just a string or thing like that. So in conclusion, and yes, the presentation is going to be pretty short. It's really hard to maintain a design system without designers. Let's be clear with that. For me, you should always have designers. If it was me, I would always do that. But let's be clear, we are not, like I said, we are not in the ideal world. And definitively, there is an extra cost to not having designers. It's require really good architectural choices, really, really good. So to go back, you need definitively MUI or ShadCN UI. Atomic design with some domain-driven decision inside, a section inside. You cannot just have a thing that your design system gonna be pure generic and everything. That's not the goal of your design system. You might have the atoms that are generic enough. In the molecular organism, start to put some domain components. A lot of React patterns, I won't repeat them all. Yes, so there is a lot of other things anyway in the design system. My goal was not to make a recipe of whatever you need to do in the design system. I really wanted to focus more on the React patterns. But there are a lot of other topics like documentation, testing, accessibility. And if you are only developer, consider your design system as a day-to-day things. There will be no vision. The goal is just what I can do to keep at every time the code base good. So, because any moment, since you don't have vision coming from designers, the designer might come every day with something that is different than what you already have. And you need to accept that. Sometimes you need to challenge, but sometimes you need to accept. Like sometimes they even, it's happened to us, sometimes they already signed with the client before coming to us. So you say, well, what should I do? Should I go say like, oh, sorry, the architecture is not ready, it's gonna take you 2 months more? No, I say, okay, we're gonna we're gonna accept your way, but we're gonna build the component in a way that your messy code is on your messy part, it is not impacting the design system. That's a bit the way we do. Do you have some question? And so there is a repository accessible there. There is all the example of the code for each of code. There is for each pattern there is all the code that can help you to reproduce them and reuse them. I did my best to accept Tailwind for the styling. I didn't use any React library to help me on the way to use some patterns. I know a lot of library exists for some of the patterns. For example, the slots pattern, there are libraries to help you. But for the sake of the presentation, I try to make it as raw as possible so that you understand the logic behind and you can re-implement it, the way you want on your side. So, voilà.